Okay. Okay. We come out of the world of straight lines again. Now, we're looking at x squared. So all of the equations that we're going to deal with from here on out in this unit are equations that start with x squared.
They use that word right there.
I can wait. Go ahead, pick your head above the desk. Up. So everything that we're going to look at now starts with a leading term of x squared. Okay? So we're not dealing with x cubed. We're no longer dealing with x. We're no longer dealing to the power of x. Okay? X squared is what you're looking for. So your parent function is just y equals x squared. Nothing's being done to it. It just sits pretty. Okay? So there's some key features that you need to know about this graph. One, it says the graph of the quadratic function is called a parabola. Okay? That's what they call this shape. They call it a parabola. Okay? Think about it. It's a valley, or if I turn it upside down, it's a hill. Okay? We call it happy face, sad face. Okay. No, it's not going to go sideways yet. That's math 3. We don't take it sideways. Math 3 takes it sideways. Okay. So your vertex is either going to be the point at the maximum or the minimum. What am I talking about if I talk maximum? The highest point. Okay. So your maximum would be a high point. This would be the highest point. So if I had a maximum, my graph would look something like this, and it would be this point right here. Okay, your highest point. Your minimum value is going to be your lowest point. Okay, I'm going to put that over here. Lowest point. Okay, and that happens when your parabola looks like this. At this point, we have something that we call the axis of symmetry. What does it mean to be symmetric? Same. Okay, so this means that if I cut my graph in half at this point, the left side of my graph and the right side of my graph are mirror images of each other. They're exactly the same. So what happens on the right side also happens on the left. So if we go back up to this picture, okay, if we go back up to this picture, this is my minimum. My minimum is at 0, 0. My axis of symmetry comes down and cuts my graph in half at that point. So my axis of symmetry is actually at x equals 0. So if I look at what happens on the left-hand side of this graph versus what's happening on the right-hand side of this graph, it's identical. Okay, look at these points. This point is 1 to the right, so the other side is 1 to the left. This point up here is 2 to the right. So on the other side, then, I have to have a point that's 2 to the left because they're mirror images. Your stomach is starting to feel funny? I'm sorry. Okay. Where did I get x equals 0 from? Well, that came from here. If my minimum is at 0, 0, my axis of symmetry is x equals whatever the x value is of my vertex. Yes, it could be 1, 0. It could be negative 7, 0. It could be 1, 2. It all depends on how I manipulate the equation. Okay. Okay. The last thing that you need to be able to find is a 0, x-intercept, solution, or root. Remember, these words are all the same. So if I ask you to find me a 0, you're trying to find the x-intercept. If I ask you to find me a root, you're finding the x-intercept. If I ask you to find the solution, you're finding the x-intercept. Okay? Don't get confused when they interchange those words. They are going to interchange them to confuse you. They want to know, did you pay attention enough to know that all of these words are the same exact thing? Do you have any questions?
You put the fan on?
Can I cut the fans off? Sure.
Can't cut them off.
Look at you being all kinds of particular. All right. So let's open this up and see what we can do. Okay. Vertex. Where is my vertex?
It's 1, -8.
It's going to be 1. It's not -8. 1, -8 is here.
1, -9.
1, -9. Okay. Your vertex is either your minimum value or your maximum value. Okay. So 1, -9. And I've already heard that this is a minimum. So where it says max or minimum, please put minimum. Okay. That's a minimum. It's a low. Okay. It's the low point of your graph. My axis of symmetry is the line that goes through that vertex. It is a vertical line that goes through that vertex. So here's my axis of symmetry. So my axis of symmetry should be at x equals, what does x equal when I draw that line?
-9.
What does x
Oh.
equal?
4. 1.
It should be 1.
I can't even see it right.
I can go down.
You don't need to see what I'm writing. You should just be writing it along with me. I can't keep moving it up and down. We just need to look at the graph.
What did you say? I didn't even, that's what I'm saying. I didn't even hear what you said.
Okay, so say, can you repeat that, please? I don't need to drop it down.
Like you repeat all of it.
Okay. All right. Your vertex.
It's minimum.
Your vertex is either your low point or your high point. So Miss Ayel has already said it's a minimum. It's a low point. As I read my graph from left to right, it goes down and then back up. So I have a low point. Okay. That low point is right here on my graph. Well, that's the point 1, -9. So my vertex should be 1, -9. Where it says maximum or minimum, you should have put minimum. It's my low point. Okay, we drew the axis of symmetry. The axis of symmetry is a vertical line that drops down through my vertex or through my minimum. Well, when I drop that vertical line down, it's at 1 on my x. So your axis of symmetry should be x equals 1. Okay. If you want to put it on the graph as well, you can. This is the axis of symmetry, and that's at x equals 1. This is your vertex, and this is at 1 comma -9, and we know that this is a minimum. Okay.
Are you serious?
Okay. They want to know, where are your zeros? Zero is just another word for root, solution,
X-intercept.
x-intercept. Where does my graph cross the x-axis?
Well, technically.
No, -2 and 4.
-2 and 4. Okay. So these are your zeros, your roots, your solutions, your x-intercepts. So you have zeros at -2 and +4. So when it says roots, you should put the same answer, -2 and +4. When it says solutions, same answer, -2 and +4. X-intercepts, -2 and +4. They are trying to get you used to the fact that they are all the same thing. So it feels repetitive. Okay. But I'm telling you right now, if they get to the point on your test and they say find the solution of the graph, and you're going, wait, what did that mean again? Okay, I need you to know those words. Your or your y-intercept. Where's my y-intercept?
-8.
-8. It crosses my y at -8. So this is your y-intercept. And the last dreaded thing, oh no, your domain and your range. Okay, remember, your domain is all of your x values that you can use in this equation or on this graph. Please remember, just because there's not arrows there, there really should be. That's an oopsie on their part. Okay, there really should be arrows here, because my graph is not going to stop.
It should get wider and wider.
It's going to get wider and wider and wider and wider and wider. Okay, I can't make my arms go that far. They're going to pop out of socket. Okay, so is my graph ever going to stop going to the left?
No.
Is it ever going to stop going to the right? No. So your domain, no matter what quadratic function you have, is going to be all real numbers.
Oh, now you want to go down.
They can write that as -infinity to positive. Okay.
So who decided that if we was gonna do a sideways 8?
The sideways quadratic is actually the square root function. I'll go back down here in 1 second. Okay. All right. Take a look at this graph. You said we have a low point. Okay. So is my graph ever going to stop going up?
No.
No. But how low does it go? Whoops, sorry. -9. So it goes from here up. So that means your range is greater than or equal to -9. My low point is -9 and my graph is going up. So it's greater than or equal to -9. You're tired.
Yeah.
You're live, awake, alert, enthusiastic.
I want to fall and then press my life alert button.
I'm autistic.
You're gonna. Did you say you're gonna hit your life alert?
Who said autistic? He said I'm autistic.
Oh, I'm falling and I can't get up.
All right, life alert.
Watch out.
My grandma has one of those.
We don't need no.
She hangs it on the wall.
Why?
I said, Grandma, what good is that? Because if you fall, you're not gonna reach it.
She could like throw something at it and compress it.
All right.
I'm falling and I can't get up.
Class says, wait.
You got legs, don't you, man?
All right.
Legs, don't you? Get up.
Take a look at this one. This time, instead of a minimum, I have a maximum. This is my high point.
You got legs, don't you? Get up.
Okay, so this is my maximum. What point is that? 1, 4. So guess what? That's your vertex. 1, 4.
1, 4. That's my vertex.
1, 4 is your vertex. Your vertex is where your graph can cut in half and be symmetric. So I should have a vertical line that comes down through this point. That's your axis of symmetry. And that's x equals what? 1. Remember, it's the x part of your vertex. And your points are always x, y. So it's going to be your 1. Or when you draw it, take a look at where it crosses your x. It crosses your x at 1. So x equals 1. Okay. So axis of symmetry is x equals 1. What are my zeros? -1 and 3. -1 and 3. Again, these are your zeros, solutions, roots,
Oh my God.
x-intercepts. He says, oh my God, would you just stop writing that 50 million times, Miss Smith? You'll never forget it.
That's the bad part.
Right? No, that's the good part. That's the wonderful part.
That part. Wonderful. No.
Where is my y-intercept? Where does it cross my y-axis?
3.
+3. Okay. My domain. It's going down and to the left. It's going down and to the right.
All real numbers.
All real numbers. Okay. Again, it's going to continue to go even though it's going down. So we're still all real numbers. The only thing that's going to change here is my range. Because now my graph goes from here down. So y is less than or equal to 4. Okay. So now because it's flipped upside down, it's less than or equal to because it's going down.
That's it. We're done with notes.
We're done with notes, friends.
Let's
Let's
No,
go.
we're not. Go down because I need.
I got you.
You know what?
Who still needs this graph up?
I did all my notes.
Like, psych,
All of them.